Welcome back to another episode of some Let's Fix It projects. So this Super 2 armature, found it online on eBay auction and chatted with the original owner, and you can see there's a lot of scratches there on the surface. It looks like they were trying to get that thing to ohm out correctly. Well, it turns out some of the wires were broke. So purchased this online and got it in here just a day ago and said, well, let's take a closer look and see if we can figure it out. I don't think these scratches will hurt anything. That's just where the little probes were sliding across the surface. That silver shiny finish, that's actually the original protective coating, and the copper under it is going to be the better connectivity once it's running. So we'll inspect these individual tabs here one at a time. I'll try to get this camera adjusted and get as close as you can, as close as I can for you. And hopefully you can check it out with me as we try to decipher what's going on. Now, according to the listing, it was ohming 12.1 across one of the poles, which to me is a good indicator. Typically these Super 2 armatures are anywhere from 4.1 to 4.5. So I'm trying to figure out exactly what's going on here. Looks like there's a little piece of a wire there, but I don't think it's broken. I don't see anything loose anywhere. I'm just trying to inspect these and see if they've moved around at all. Whatever the case may be, when they wound these things new, they always had them right on the edge from the leading, or rather the trailing armature pole. Aha! Now, looks like we found the culprit here. And it appears to be two broken wires. Now the question is, are they inside or outside wires? If they're outside, this might not be too bad of a project to see if we can get it fixed. I think what we'll do here is maybe we can bend this prong out just a little bit, get a little working room and some space, and see if we can't unwind a single wind off of this pole. It's not going to take much. We just want enough room where we can gently pull those wires around, get them by. A single wind is not really a big deal to unwind off of these. I mean, you're talking probably an inch or less, to be honest, that you're actually shortening up the length of that wire. You'll see virtually no difference in that. If anything, maybe a 0.1 in ohms. Not enough to be able to tell any difference one way or the other. Looks like we got one of them pulled out from in there, trying to get a hold of this second one. Let's see if we can get it over here. Yeah, got those out. Well, the good news is it's on the outside of the wind, which makes it pretty easy to get some extra length. Now we've got those loose. We could probably just go ahead and pop that plate back on and bend that prong, and that way we don't have to worry about taking a chance on breaking into the others by that plate getting caught. But that's a plenty to get wrapped back around there, and you can see there that's about maybe 3/4 of an inch of wire extension there. And you got to remember, at the very tip of that was originally attached, so it's not really that much, not enough to, again, have any noticeable difference. So we'll go ahead and take the time to lock this plate back into place. That way we don't have to worry about it sneaking away from us, accidentally hanging it on something, and then taking a chance on breaking any of the other wires. So we'll just lock that right over. And I noticed too, this one's, when it comes from the factory, it's pretty close to dead center of the com plate, which is kind of unusual. You'd see a lot that were off center, but this was actually in pretty good shape, the way that they milled that center hole. So now let's get this thing into the vise where it's a little bit more manageable. And what we're going to do is just use a bit of a hard surface here to sand against to keep those wires from moving around. We'll sand it a couple of different ways. And what we're trying to do is get that enamel coating off of it. The solder doesn't like to stick to that enamel coating, and that's just to keep the wire from shorting out as it runs around the armature poles. But when it gets towards the end, if you don't get that stuff off of there, get it real clean, you won't get really good contact with the comm plate itself. So it's always good to brush these off a bit. And then I usually just do it a few sides on each side and just flip it over 180 degrees. Just give it a real light sand. Now, if you've watched some of the other videos, I talked about how the windings themselves on the armature, they'll get dark and really dirty and dingy for armatures that are well used. This particular one looks like it's been used zero. And probably because it was broke early on and it wouldn't run right, or it wouldn't run at all, rather. With two broken wires, it wouldn't run at all. And so the wiring on it is actually in pretty good shape. It's not nearly as brittle as one that you would see that's been through quite a few heat cycles. Got this one wire, it's trying to be elusive on me. It's trying to coil up. Again, I'm not pulling real hard on this, just giving her a light sand. When you're against a hard surface like that, you can take a chance, and you will take a chance on breaking that wire. So I think what I'll do is I hit it a few times using my fingers, kind of that backstop, so it gives a little bit of a softer feel. Plus I can tell how hard I'm actually pushing against the wire here too. And I'm trying to get right up next to the armature, because as soon as that wire starts to loop around the tab on the comm plate, you'll be trying to make that solder connection. So it's good to get it cleaned as close to that plate as you possibly can. And then I generally try to make at least a couple of loops around the armature tab itself. That way you know you're going to get good connectivity there. So pretty pleased with how that turned out. We didn't break the wire, which is always a plus. Though you'd have to unwind another loop. We don't want to do that. It's already shortened up enough. So now we'll take our time and see about getting it wrapped around the tab. And just taking a look at the other wires. You see the wires broke, so we didn't actually heat that up and try to get the old wires off. We're gonna just leave that alone and see if we can't lay them down pretty tight here. So that's one loop around. Here's the second. And if we can get them to lay flat, as long as they don't drag and touch the chassis, we'll be okay. The weight is so nominal in terms of the weight of the wire. Having a couple extra strands on there is not going to hurt a thing in the world. But what you certainly don't want is to get it so built up that it's hanging down too low, and then you run a risk of the actual tab dragging. If it gets too close, we'll take a little sandpaper and just trim it up, just to be absolutely sure. But again, you want to be super careful that you don't sand through the wires themselves. So we've made two passes across the solder contact on the comm plate, so that's pretty solid. And these wires are actually really good length, where they're basically going to make two passes across the back. without too much extra. So we're not really wasting anything here. And these little guys, they'll sometimes have a tendency to try to slip off when you go to solder them. So we'll go ahead and put a little bit of glue on here. We'll lock these in place. And that way, once we go to solder, we don't have to worry about the wires that are already soldered on once they break loose slipping off, or the new wires that we're putting on. We'll just kind of pin them down right where they are. And with these Super 2s, it's always a good idea to do this anyway, regardless of whether you're actually doing a repair or you've got one in great shape. If you plan to run it at all, these windings were so fine and they were kind of sloppy when they actually made them, that once the centrifugal force hits them, those high RPMs, they have a tendency to sling them loose, and the windings will loosen up on them. So a little bit of glue, and I think Bob Beers and some others would use a toothpick to kind of spread it around. I just use a fine point Q-tip. You can buy those at any local hobby store. So I use UV glue. It'll dry up, and you don't have to worry about it being sticky. And then I can go ahead and squeeze it down, and then make sure those windings are very tight against the com plate itself. And now I don't have to worry about them slipping off of there. I'm making some good headway here. Just making sure they're up on the com plate good. We've already got a good bit of solder on there, so we'll see what it looks like once we go to heat it up with a little touch of flux on it. We may add just a little bit more, just a tiny little bit, just to make sure that it gets good saturation in between the wires and good buildup. So we'll put it back in our little jig now, hold it still for us. Get you a good close-up so you can kind of see what I'm doing. Right now, we're going to put a little flux on there, and that's just going to help clean those connections really, really well. Any contamination on there, help get that off. And you can see I'm kind of going the direction of the windings. We don't want to take a chance on grabbing them and pulling them loose. Thing I'm doing right now is kind of waiting for that thing to get hot. Also went ahead and got a little solder handy, so I'll be ready. Get that solder close by, and while we're waiting for that solder iron to get hot, we'll give it a little test here. Plus that adds a little rosin to the end of the tip, and then we'll clean that off. And that way we're confident we're gonna get a good heat transfer. You can see that flux works like magic. Settles on in there, cleans up that contact real nice. And the solder is gonna run towards the heat. So I don't know if you've ever soldered copper pipe or anything like that, but wherever you put that soldering iron, the solder's going to run to it. So I think we'll probably put just a little bit of piece of solder on here, a little extra, super thin right here. While it kind of ran on the wires, it really didn't coat in between, and I want to make absolutely sure those wires are going to stick. So we'll put a little extra on here. But yeah, it's if you do copper pipe, you actually heat towards the inside of the joint, and then put your copper on the lip, on the outer edge, and then as you heat it, that stuff will run on in there like gangbusters and seal it on up. It's pretty wild. I'm no expert by any stretch of the imagination, but the more I do this, it seems better I get. And she wants to be a little finicky, and I keep hitting it here. It's kind of slid off. Let me scoot that back on. If I touch it with the soldering iron, it's liable to melt it. So let me use these tweezers, get it a little closer there. And hopefully I can be steady. And once she melts, boom. It's just like magic. Just flows right on out there. It's crazy. And I get on and off a couple of times. You don't want to get too crazy with it. If you do, you take a chance on, the glue that they use to glue that contact tab down to the actual fiber plate. You run a chance on that kind of breaking loose. So you just dab it a little bit at a time. The iron's good and hot and clean. She'll lock on in there pretty quick. It don't look too shabby. It's got a bit of a tab. I might touch it with a little sandpaper here, just to kind of knock that edge off. It turned out pretty good. And you can see on the other two tabs, they use a machine when they were making these things. They glued them, soldered them, and then they would spin them through a machine that would knock an edge off of them. Of course, I don't have that machine, so it won't be 100% exactly the same, but sanding across the flat here will give a little bit of that perception that it was flattened out. And again, that's all with the idea that you just don't rub the chassis on the bottom once this thing spins up. I'm pretty satisfied with that. Touch it up a little bit. And hopefully we can we'll get an ohm test on it here in just a minute, and I'll show you folks how it turned out. You can see what the ohms are from complate to complate tab, and maybe we can even get a bench test in here where we can see what it sounds like when we put it in a chassis. I've just got a basic magnetraction chassis, and I think it's got X-traction magnets in it, so it rips pretty good in this chassis, but otherwise it's pretty much stock. Now I'm just cleaning it with some alcohol, get that flux residue off of it. Makes them look pretty good, and looks like it's got a little bit of something right here. Let me try to get that off. I don't know what that is. Paint or something. I don't know. Get that cleaned off. Yeah, lots of scratches on the surface here. They're really going to town on trying to get it to ohm out correctly, but she was not going to happen. Those broken wires, once that happens, that's all she wrote. I know in some of the other videos, you can take a look at how I've saved the wires, even when they were broke on the inside piece, although it's a bit more tedious to fix those, and you have to pull the complate all the way off to really be able to get to them good, which is a little tough. Of course, anytime you're disassembling one, especially when they're not broken, you always run the risk of breaking them. In this case, it turned out pretty good. I think we'll go ahead and glue some of this down just to be dang sure we don't run into another similar situation. I like the UV glue a whole lot. I won't say it's the strongest, and it's certainly not as thin as regular super glue, so some folks like to use super glue, the super thin stuff, because it'll absorb in between the windings and really bind them together. But I think this does fine. The main thing is the surface. You just don't want it getting away from you and just completely unraveling. And then I try to put a little bit on the wires as they cross over the comm plate, just to keep those from moving around accidentally, just bumping them or whatever the case may be. And as long as you do it pretty much evenly across each one, it's fine. But it really pins them down to where if they won't start moving around with that centrifugal force and take a chance on breaking them off. I think that happens more often than not. I'll take a dry end and kind of smooth that down. Get the excess buildup off of there. No need to build it up no more than necessary. And hit this with a UV light and lock it in. And this will pretty much make it tack free. It'll set up hard in about 24 hours or so. Yeah, I think it's pretty good. I want to move our little jig out of the way. And we're getting pretty close here. Take another inspection here. Get a close up. I had it turned down. Yeah, so I think we've got it all squared away. And we can do a little ohm test on it. Here's a close-up shot with the glued down wires. You can see what that looks like. Doesn't affect a thing in the world. So yeah, let's put it in our little stand and whip out their fancy dancy little ohm meter. I know I did a couple custom rewinds and listed them on eBay, and they're ohming about the same thing as the Super 2. They're single wire winds. I call them the Wildcat. But I had somebody challenge me on my own reading, so I went out and bought this $300 Fluke. And I dare somebody to challenge me now. This thing is the cat's meow when it comes to ohm meters. You can't get better than a Fluke. What I had before was some little Harbor Freight special. It was pretty close though. It wasn't but 1 or 2 off. 0.1 or 2 off. 4.2, 4.3, 4.3, 4.3. Well, you can't ask for that much better than that. 4.2. And I don't even know that that's the one we worked on. I mean, when you're that close, it's just spot on. You can't ask for much better than that. There's no such thing as perfect. It could be how I was holding the probes or where I was touching on the comm plate. It could be anything to make it deviate a half a point one way or the other. So, well, not even a half a point. It could be less than that. As a 1/10 of a point would be 0.1. So it's like a 20th of a point. So I'd say that's about as daggone near perfect as you can get. And I'm pretty happy with that. So let's use this little test chassis I have here. We'll pop this mean green out of here. Zoom in so you guys can see what's going on. Now this camera is kind of all over the place. And then I'm going to flip it over, and once we get this ready to test, we're going to stop the background noise, and I'm going to shut up, and you guys can hear what it sounds like. Take but a minute to get this swapped over. I got a little test plate. I don't even put a top gear on it. I just let it sit on the brushes and just drop that armature straight in there and put my little test plate on. Go from there. I'll just wiggle it around until I know it seats in with the brushes. And I'll just clip this little bad boy in here. Give it a quick test and see what it does. There we go. That's better. Now you can get close up. All right, well, what's it gonna do here? Well, dead as a hammer. Well, it helps if you plug in the power. Yep, so I forgot to do that. So we get the power plugged in, then we'll give it another shot. All right, give it a bump. Aha. All right, let's put a little touch of oil on it. We don't want to run it too long. Dry. Just a little something here. And we'll give it another quick go. All right. Well, listen, appreciate you guys watching. Don't forget to like and subscribe, and that way you'll be updated on more releases. I do have more stuff coming, and I appreciate you watching. Thank you again. See you soon.